chemistry and we're in chapter 5 and we're on the section 2 and we're going to talk about gas. In this part of we're going to talk about gas pressure and we're going to find out what some gas pressure units are and how to measure gas pressure. So as looking here at some of the pictures, we have the mercury barometer. So we're going to talk about different barometers and how they work with gas pressure. Well, let's go back understanding gas pressure with kinetic energy. So kinetic energy, we know, is basically the molecules move around in constant motion. This is called the energy of motion, and it's related to their mass and their velocity. How is it related to mass and velocity? Well, let's look right here. You have your formula here. So we have kinetic energy is 1/2 mass times the velocity squared. So that's just basic. This here we should have learned actually last year, but kinetic energy is 1/2 mass velocity squared. So just so you know that, to recognize that. The kinetic energy and velocity depends on the temperature though. If you have an increased temperature, you're going to have an increase of kinetic energy, right? Because energy makes the molecules go faster, or temperature makes the molecules go faster. And when temperature falls, the kinetic energy falls because the molecules go slower. So now we're going to talk about something a little different than that. We're going to talk about pressure. This one you need to know. Pressure. What is pressure? Pressure. When the molecules are bumping against the side and you get more molecules, there's going to be more pressure inside that container. Here we have a balloon. If we get too much pressure inside that container and it's going too fast, maybe the temperature goes up or down, then we'll know the pressure getting that way. You're going to have it's going to pop, really, the balloon. So the pressure. So pressure is a force. So we look at pressure. Pressure is the collisions of gas molecules with the container, in the container there. And it's basically the force. And the force is the push, or how they're pushing each other. And that's per unit, and area is the per unit. So let's look here. The collisions of gas molecule with container wall against the container walls constitute pressure, defined as a force per unit area. So the definition, you're going to say force per unit area is going to be pressure. So pressure equals force over unit area. F over A. Force over A. So F over A equals the pressure. And it's a large P, not a small p, but a large P. So that's pressure. That's how we're measuring. The pressure they exert is the same in all directions. The SI unit to measure pressure, what's the basic unit for the world, is called pascals. And it's based on, a pascal is now a newton. What's a newton? A newton is basically that force, that SI unit of force per square meter. So newton is just measuring it by each square meter. So pascals and newton. But pascal is the universal unit they use to measure pressure. So here's a picture of this balloon here. It says molecular motion produces pressure. You see the pressure in that balloon. That's why the balloon blows up, right? So let's go on to measuring gas. Measuring gas, let's see. How do we measure gas? Measuring gas is now measured by what's called barometers. So barometer, here's one picture of a barometer. Let's look at the other picture of a barometer up here. Here's another barometer here. So this is a simple mercury barometer here. And so a barometer, mercury barometer was invented in 1643 by, his name was, let me show you how his name looks down here at the bottom, very bottom. Evangelista Torricelli. So Evangelista Torricelli. So we just call them Torrs or Torricelli, and we're going to use Torrs to measure pressure too. So here we have a barometer. So the barometers, the mercury was invented in 1643 by Torricelli, right? And basically It also, as you can see here, as the air pressure goes down here, then as the air pressure goes down on both sides, it's pushed up this vacuum. This is the mercury tube up to the top, and then it measures with the pressure. When the air pressure gets actually lower, then it's going to go down in pressure. So at high elevations, the column is not as high up as on lower, because the air at high elevations is thinner. So basically at high elevations, the column will go down. And when it's fair weather out, nice weather, we have a high atmospheric pressure. So it measures high when it's fair weather. When the storms, we say we have a low coming in. That means we have a low atmosphere coming in, and a low storm will make us basically having low atmospheric pressure. So that's how they measured pressure. That's a barometer. There's another kind of barometer too, and that's a barometer down here. Let me give you a picture of that barometer. That barometer down here is actually an aneroid barometer, another type of barometer. What that does is, have you ever gone in an airplane and you have, you have something in a plastic bag? Maybe you have, some food in a plastic bag or a container, a vacuum container. And as you go up to high altitudes, it looks like it's going to burst, and you get it out. You get out your toothpaste or whatever's in there, or whatever it was in it, or whatever, you get it out and it looks like it's bulging all over, or it has the air in it has got came bulging. And that's how this anaerobic. Basically, when we have an increased pressure, the walls of the box are squeezed inward in the inside pressure. That means when the outside air pressure is greater, then the box is squeezed inward. In an airplane, the outside pressure is going to be less, and so the walls will bulge out. So this goes by the bulging. So you have the spindle here that measures here, and this is the evacuate, but it depends on how is it pressure squeezing it inward or outward, and how much to measure the aneroid. So it's a different way. It's a little different than the mercury one here, but it measures the walls of the box squeezed inward or squeezed outward. So those are basically the pressure units of the anaerobic. So let's see. So you see, okay, let's go on. We're going to go down to the pressure units, the table of pressure units. How do we measure pressure? We already know pascals is the SI unit. So let's find out about some other units. Oh, excuse me. Here we go in this table. So here's our table. So we have, first of all, we have a Pascal, which would be PA. Well, relationships of units. Let's see. I think there's some units down here first. These are some of the ones we use all the time, but there's even more units. Thought there was another. Here, let's go to my notes here. See my notes. Yeah, here we go. Pressure units. So this, so basically, a Pascal is our SI. That's our scientific, international unit, which is Pascal. Another one is when we were measuring on that mercury barometer, we measure in millimeters of mercury. And so a millimeter is of mercury. But that doesn't always, it's affected a lot by gravity, so they don't always use that. But they use what's called a torr. Remember, what is his name? Torricelli, right? Torricelli, they call it a torr. So we have Pascal. He's another scientist they named after, Pascal, if you know him. Both of these guys are just dynamic Christians. In fact, his name is Evangelical Torricelli. So anyway, but this was back in the 1600s. And so 1 millimeter of mercury is going to equal 1 torr. So we can either go by a torr or we can go by millimeter of mercury. So torr or mercury, either way. So just know that that's important because it'll be on a test question. So 1 millimeter of mercury. Mercury is, symbol for mercury, as we learned before, is Hg. So 1 milliliter of Hg is a torr. And it's defined in pascals because 600 or 760 torrs equal 1 ATM, and that's the next. We have a standard ATM, which we call an atmosphere. So a standard atmosphere is going to be 760 torrs, or 760 millimeters of mercury. See how they go? How many pascals? Well, 760 torrs is going to be 101,325 pascals, or 101.325 kilopascals, which are 1,000 pascals. So you see all that here. Move this over so you can see it right there. There's the pascal. 760 torr, 101,325 pascals, because pascal is a very, very light measurement. And so we can also measure in bars. Not very often in bars, but they do use them for meteorology, which is weather. So if you're on the weather station, they'll measure pressure a lot of times in bars. And a bar is going to be 10 to the 5th. That means a 10 with, 5 zeros behind it, pascals. Or one microbar is going to be 10 to the negative 3 bar millibar, or microbar, millibar. I said microbar, it's a M, it's millibar. So anyway, bars are another way. So if you were measuring pressure in a balloon, you can measure it by pascals, which will have a lot of them because it's a very small unit, or you can measure in milligrams of mercury, which is equal to a torr, which a torr in 1 ATM is 760 torrs. So you're going to have to know all of these. It's kind of important. So just know pascals are very small, milligrams of mercury are equal to torrs, and this number is important, 760 torrs in an ATM, which is an atmosphere, a standard ATM. And then if you're in meteorology, you're going to do bars. So basically we measure in torrs and sometimes milligrams in mercury, but mainly in torrs and ATMs and pascals. So now let's go back. We're going to talk about another type of barometer, another type of way to measure pressure is a manometer. And a manometer is what you use in the laboratory. So let's go and look at these manometers. So let's go up here first. So here, this table here tells 1 torr equals 1 millimeter of mercury. And then we have 7.5 times 10 to the negative 3 torrs for a pascal. 1 bar is 10 to the 5th. Then we have all these. But always remember 1 ATM equals 760 milligrams of mercury, or 760 torrs. This is a pretty important number that you remember. Okay? So now we're going to talk about what's here called the manometers. So, all right. These manometers are basically another type of how to measure and the pressures and stuff. Manometer, let me go over that. Our common laboratory device used to measure pressure. There's open end. There's 2 different kinds. Here's a picture of them here. Hopefully you can see this well. There's let me see if I can move it down any further. No. There's the open-ended manometer, and then these two, this is an open end, and this is going to be the closed end. So how do we use these things? So probably sometime I'm going to be able to use them. So basically, if you look at the side here, so we have this side and this side here. So here we have the valve closed. When it closed, basically the atmospheric pressure. This one here is we have to do way more more calculations. Basically on a closed end manometer, you just go ahead and take the reading, right? So as it's a vacuum tube there, and as the pressure comes in here and goes up, you can see how the pressure came in. Okay, here's the pressure coming in. It's going up. It's going to move this right up here, this much. It moved it up 350 millimeters. So we're going to say there's a 350 millimeter change there, right? So it's going to be 350 torrs. So that's the gas. Okay, this here is going to be harder. And so you're going to actually have a problem on here, but it's not really that hard. So basically you're going to have to realize you're going to have to subtract. You're going to either have to subtract the reading that you have there, when I say a subtract or add, so if you have, say you have 30, a difference in there, let's see, we're going to do a question on that, but not just right now. The difference on the open end, you have to subtract. You see the sample is greater pressure or more push, you find out which one, and the difference in height, you have to subtract that from the 760 to find it. So, okay, so this here, we basically, it looks like there's a difference of height here, or the difference of height as it goes up is 400 millimeters. And so we have 400 millimeters, the difference in pressure. And so we have to subtract that, or add that 450 to 760, because the pressure of gas is going to be greater than the atmosphere pressure. So whenever the pressure of the gas is greater than the atmosphere pressure, then we're going to have to add it. So it's 760 plus 400 torr equals 1160 torrs. On this side, we do the same thing, only as we see the gas here being 760 torrs, and then we'll see basically as the difference as the pressure goes down, as pressure is going down, we have 450. So we're going to subtract from the 450 from the 760 minus, and then we get 300 torrs. So it depends on if the gas is lower than the atmosphere or higher than the atmosphere. If it's high, the gas is higher than the atmosphere being this. If it's higher, then we're going to add, and if it's lower, we're going to subtract. So it's a little bit complicated. It's actually easier to have a closed one, because then you can just take the exact amount, 350 that it changed 350. There we go. So, okay. I hope you knew how to do those. Those are kind of a little bit harder. So let's go on and see what else we have here. Just to know that these are manometers. So, okay, let's go over the example so we can find this a little clearer. So a sample of gas in a flask is attached to an open-end manometer. For each of the following measurements, determine whether the pressure of the sample of gas is greater than, less than, or equal to the atmospheric pressure, and calculate the gas pressure if the atmospheric pressure is 753. So let's look at, first of all, the mercury level on the atmosphere side is 33, higher than the level on the flask side. So what are we going to do? Let's look down and see what the solution says. Whichever side has the greater push on it will be the lower side. So in this case, the side towards the atmosphere is higher. Atmosphere is higher. So the gas must be pushing harder than the atmosphere and is greater than ATM. So if the gas is greater, we have up here at the top here, since the gas is greater than the ATM pressure, atmospheric pressure, the pressure difference is 33, so we must add. If it's greater, then we must add. 753 plus 33 torrs equals 786 torrs. We had to add. So now let's go on B. The mercury level on the atmosphere side is 45 millirees lower than the level on the flask side. Remember, lower, so it's lower now. So the mercury level is lower on the atmosphere side, so that means basically the gas on one side is lower than the atmospheric pressure. This is what we put as just means the same thing as this. So the pressure difference now is 45 torrs, so it must be subtracted. So basically, when you know that the atmosphere is lower, you're going to subtract. If it's higher, you're going to add. That's how you do those. So those are your examples. Let's go on to this last example here. The difference between the two mercury levels in a closed end, okay, now we're on closed end, is 345. What is the pressure? It's closed, so we don't have to worry about that atmospheric pressure, do we? So what is it going to be? The answer is going to be basically that, 343. You read it. It's in a vacuum, and that for a closed one, it's just going to be 343 in the closed. So let's go to this little section here. It's kind of a neat little section. It's basically just talking about the pressure that you create when you're sucking on a straw and how the straw comes up with that pressure. So the gas and pressure in milkshakes. You reduce the pressure in the straw when you're sucking on the straw. And so the atmosphere pressure then is greater than the inside of the straw. So this forces a vacuum in the inside of the straw and forces the liquid up into your mouth. So, but it's not a total vacuum, just reduces enough pressure, usually reduces 11 torrs so the beverage can reach your mouth, right? So see how it is. So basically right here is 749 torrs, and here we have 15 centimeters, and as you go with the torrs, the atmospheric pressure 760, you can see the different here. Here's when it's longer, here we have a longer, it's going to take a little bit, it's going to take 569 torrs up here, and it's this long. So you see the difference here with the atmospheric pressure, or I should say the torrs. So you can just see the atmospheric pressure is pushing down here, but as you're sucking on it, you let up the atmosphere and it turns a vacuum, which brings up, just like that mercury thermometer, brings up the liquid. Some review questions here. I'm not going to do all of these, but just kind of go over it. How are millimeters of mercury, torr, and atmospheres related? Well, just to know that the 1 millimeters of mercury equals a torr, and there are 760 torrs in an ATM, or atmosphere. So you'll need to know this. What is the standard pressure in the torr? The standard pressure in torr of the atmosphere pressure, the standard pressure in the torr is basically what is standard pressure in the torr would be the pascals in the torr, right? Or basically in the ATM 1 atmospheric pressure, which I thought it was, is 760 torrs. So what is a manometer? Manometer is a common laboratory device that measures pressure, right? So the review here, our application says, convert 56 millimeters of mercury to torr and atmosphere. Well, 56 millimeters of mercury is going to equal 1 torr. These two are the same. That's pretty easy. So, and on to that 1 atmosphere. 1 atmosphere is going to be 760 torrs. So this is the same as we got up here. A sample of gas is connected to an open-end manometer. Determine the sample's pressure in each of the following situations. Okay, this is when we're talking about the open end, when we have to subtract or add, remember? So basically the first one here, we have the mercury level is 12 millimeters higher in the side open to the atmosphere, so that means higher atmosphere. So if the atmosphere pressure is 783, then you're going to add that 12 to the 783, right? And we'll get 795 because it's higher. If it's higher, you're going to add. 783 plus 12 is what? Let's see, 795. The mercury level is 37 millimeters higher in the side open to the gas. So that means it's going to be lower. It's open to the gas, not the atmosphere. So since it's open to the gas instead of the atmosphere, it's going to be lower. So the atmosphere pressure is 759, then you're going to subtract that 37. And if you subtract that 37 there, you're going to get 722, right? Because you subtract. The difference between these is it's higher in the side of the atmosphere, and this is higher in the side of the gas, which means it's lower in the atmosphere. So the atmosphere pressure, you're going to subtract that 37. So the mercury level is 115 lower in the arm open to the gas. So the atmosphere pressure is 1 atm. State the answers in atmosphere. So basically you have you're going to have, it's lower in the arm of the gas, which means it's going to be higher in the atmosphere, so the gas is going to be higher. So you're going to add the situation, you're going to add 115 millimeters, right? 115 millimeters to the pressure of the gas at 1 atm. So basically you're going to have to, 1 atm is 760, remember? 760 torrs, or 760, so you're going to add 760 to 115. So 760 to 115 is going to be 875 for that. Just know, if always go by the atmosphere pressure, it's going, if it's higher or lower. If they're representing gas, then that means the atmosphere is, like this is higher in gas, well, it's going to be lower in the atmosphere. Just which side you're going to look at. So let's see. Number 3 says, a gas sample is connected to a closed-in manometer. Okay, closed-in is pretty easy, right? The difference in mercury levels in the two arms is 115 millimeters. What is the gas pressure if the atmosphere pressure is 750 torrs? So basically it's going to be 115 millimeters, or 115 is going to be the answer, because you don't have to add or subtract anything. It's just this. State the answer in both torr and atmosphere. So torrs are 115, then you're going to have a degree, you're going to have to divide it by 760, which I didn't do, but basically it's, if you do, divide 760 by that. But anyway, you're going to have to do that. So it's 115 divided by that. So 115 torr and 700 torrs, so 115 divided by 750 torrs. So you can do that on your calculator. I don't have a calculator with me. So that's it for that section.